And welcome to another episode of Flying with TFC. In the last episode, we took the trip in the DeltaGlider to the moon, and here we are parked in lunar orbit about, let's see, a low orbit, 15 kilometers on the low side, 46 kilometers on the highest point of the orbit. It's mostly circular and has an orbit. We're going around once every a little bit over 2 hours. And I said in that last video that once I'd had a chance to practice it a little bit, I was going to go ahead and attempt a landing, and I will be doing so. In reality, of course, there is no base on the moon. However, in the simulation, there is Brighton Beach, which is located here. And now, let's see. Okay, let's have a look here. Base sync. We don't. Let's see. If we were to actually wait, our closest approach would be 178 kilometers out, and that would be 8 orbits from now. But I propose to not wait that long. And frankly, even with time acceleration, this procedure can take 35 or 45 minutes, because once you get so far into the process, you can't use time acceleration because it throws the instruments off really badly, and you will more than likely crash or go flying off into space somewhere where you can't come back from. Okay, ship status. We have plenty of RCS fuel for the thrusters, and we have 3,940 kilograms of main fuel for the main engines, retro engines, and hover engines. Now I need to basically orbit around until I get to, I believe it's about here, and then turn the ship at a 90-degree angle to the orbit and basically tilt the orbit. If you think of the orbit as kind of like as if it were, say, a circular piece of steel going through a sphere, and basically this maneuver will be to position the ship on the edge of that circle going around the sphere and push on the edge of it to tilt it in one direction or another, so that the orbit represented by these green lines here actually crosses over the base in some way. And that way we're all lined up with the base, or at least basically lined up with it, and then we fine-tune it on the approach. And that makes landing a whole lot easier and a whole lot less expensive in terms of fuel. Had I thought far enough ahead when I was plotting the trip out here, I would have made at least one mid-course correction that would have adjusted my orbit so that it would be lined up with the base right off the bat, and I could have landed right on the first orbit. So now, accelerating time. Until basically this number counts down to 0, where we'll be at a point in the orbit where it's the best time to do that tilting the orbit maneuver. And that should be when we get to about here, I think. Yes. This circle representing our orbit, the green line our position in it. Okay. This way we'll get the most amount of change with the least amount of fuel. Okay. And this plus indicates to turn orbit normal positive, so that we're facing the right direction, edge onto the orbit. Now we just burn the main engines, and as I do that, you'll see the shape of this green line change. It will become more steeply inclined until it finally lines up with the base, actually crosses the base. See the line getting closer. That means on our next orbit pass we'll be able to actually land. You see there's actually several green lines representing the next several orbits. What I want to do is stop when the first one gets over the base. Okay, looking good. Zoom back out, and you can see the orbit's shape has been drastically changed. Well, actually the shape is still circular, it's just that it's been tilted by quite a bit. And now, kill thrusters, and I'm going to warp time ahead until I'm actually approaching the base, which is a fast way to kill 2 hours in a few seconds. And of course we're at the high point of the orbit, which is going to mean a lot of deceleration and a lot of time to lower the altitude. Okay, we're 1900 kilometers away. And I'll want to get into position to start a braking maneuver about 400 kilometers out. Kilometers, 700. Okay, good enough. We're back in real time, and we'll turn retrograde, which will face the main engines toward the base so that we can use them to kill most of our velocity. Now I'll bring up base sync again. No, actually I need the VOR VTOL thing. I've already got my nav radio set. Nav 1 will line me up with the base. Oh, wait a minute. Let me check those settings. Object info, spaceport, Brighton Beach. Okay, I need to reset that nav. 116.3. Okay, and then go to nav 2, and we'll set that one 132.7. And that is selecting pad 6 at Brighton Beach. So this first one will guide us to the base, and the second one will guide us to the exact landing pad. Now this is showing the green line indicates the direction of the base, the yellow line indicates, the yellow arrow indicates the direction our velocity is, which I now need to start reducing quickly. As you can see by the way this green line has changed, our orbit is no longer an orbit. It is an eventual impact on the surface. The idea, however, is to control that impact. Switch the HUD to surface mode so that it's actually a soft landing that we can survive. It helps if you're going to thrust in circle to have it set on rotational mode. Still want the main engines lined up with the base though, because at the rate I'm approaching, the retro thrusters would not be enough. .188 kilometers out, closing at 700 kilometers per second. Or 700 meters per second, excuse me. And of course you can't see the base at this altitude or distance. But it's out there somewhere. There's the base, there's our position on the green track, which is our course. What I'm trying to do is decelerate enough so that these green lines end right at the base. Start bringing up the hover engines. Just in case I need them, open the retro doors. Slow our descent. turn it into a climb. The autopilot hold our altitude. Let's put the base in front of us. Is dead ahead. Accelerate just a little bit to get closer to it in a reasonable amount of time. Go ahead and kill some altitude. Just not too much too fast. Still 119 kilometers up. Fuel's down to 2300. Let our altitude bleed off. This is the part that is time consuming. I might actually speed up some of the video of this. I can't speed up the simulation or I'd lose control, but I can speed up the video in the editor. So I may do that. And oh, by the way, just in case anybody's wondering, what you're looking at now is the realism settings that I'm using for the simulation. And basically what it means is that I can run out of fuel, I can crash and get destroyed and so on. So if I don't touch down good, it's toast. .
1
a signal from nav 2, we'll be able to line up with the exact landing pad we're headed for. I guess I have to be within about 50 kilometers or less. I'm not sure. Slowing the descent. Let the autopilot maintain this altitude for a little bit. While we work on closing on the base. And now I will probably go back into speeding things up in the editor, because I know this is time consuming. And in real time it would probably be very tedious to watch. And now you can see the base just ahead there, or barely make it out. Still kind of far out. 30 kilometers and closing at 52 meters per second. Let's see if nav2 is active yet. Yes, it is. And we are lined up with pad 6.
1,000.
Altitude now less than 1,000 meters. I'm going to zero out our vertical velocity again. Let the autopilot take it while I line us up over the pad. I'd kind of like to be able to close in faster, but every time I've tried to do that, I've ended up crashing. On this display, green X is where we're going, the line, green line is the direction it is, the yellow arrow is the direction that our velocity is taking us. This red circle represents the landing pad. When it turns green, we will be able to actually be over the landing pad and able to actually land on it. Right now it's Something that happens a lot in space travel, a waiting game. Doing all the right things, it just takes time for it to play out. 1,500 kilograms of fuel left. Easily enough, easily more than enough. And the good part is that once we get landed on the pad, we get refueled. Close enough now we can actually see it out the cockpit window. Granted, it's a little more than a speck on the horizon just yet, but we're getting there. The thing is that there's actually a base land autopilot that I could start up and let the autopilot do the landing, but I think it's more realish to do it manually if you can. Now less than 1 kilometer from the pad, and you can see it ahead of us.
Translation.
Using translation thrusters to keep us lined up. I hate to come this far and overshoot. now less than the length of a football field in front of us. Our vertical horizontal speed is almost all but killed. Now, take off the autopilot and start controlling the descent. Landing gear down. Gave it too much up thrust.
300.
Need to keep our descent rate nice and slow.
200.
I do believe we're down, but we're not on the pad. That's embarrassing. But
rotation.
okay, now we're on the pad. And just to convince the thing that we actually landed on the pad, I'm going to lift off and set down.
Translation.
Okay. And there's proof that we landed. We have been refueled. Thank you for flying TFC space lines. Alright, there we are. It wasn't a very good landing, but it was a landing you could walk away from. Because if it wasn't, we would have crashed. And over here, There's a couple of other ships already sitting here. A Shuttle A type class vehicle, which is a workhorse cargo vehicle meant for short hops around the moon and even into low Earth orbit. And over there, let's see if I can get a better view of that one. That's a really kind of a nice ship. Let's see. Let's see. Yeah, there we go. This one is an add-on ship for Orbiter. It's called the XR-2 Raven Star. It looks like kind of like a fighter plane, but it is a fairly capable spacecraft. Quite capable. It's one of the coolest things that I have found in this thing so far. And this ship will be used in the next flight, which will be leaving from the moon and departing on the long journey to Mars. Take it easy, and I'm